Earlier we have discussed about that lens maker's formula and thin lens formula. That is lens maker's formula is 1 by f is equal to mu 2 by mu 1 minus 1 of 1 by r1 minus 1 by r2 be the lens maker's formula when the two mediums, when the lens are placed in air, means the lens having that one refractive index and another one is some of the medium air or some of the medium, wherever two mediums are there, then this is the lens maker's formula, that is 1 by f is equal to mu 2 by mu 1 minus 1 and 1 by r1 minus 1 by r2. Then next from that equation we can find out that thin lens formula, that is whenever the image is formed at some focus when the object is from the infinity, then we can get that 1 by v minus 1 by u is equal to 1 by f with the equation. Whenever we compared both equations, then we got that 1 by v minus 1 by u is equal to 1 by f. From that equation we can write that formula of a lens, thin lens formula or lens formula. If the more mediums, when the lens is placed having that more mediums like more refractive index, when the light is passing from the air and enter into the glass, from the glass to the water, means there are three different mediums is there. Like that, whenever the lens are having the three different mediums which is having refractive index of mu 1 and the lens having that mu 2 and another medium mu 3, like that, and means when the light is passing from the air to the glass and glass to the water, or either any three different mediums, when the refractive index will be mu 1, mu 2, mu 3 we are taking, then the lens radius of curvatures is r1 and r2 be the lens radius of curvatures. Then from that, if we take this one, then lens maker's formula becomes, because of we already know that the mu 3 be the final image is formed at mu 3 at a distance of v. So that's why the image final distance formed mu 3 by v minus where the light is coming from, that is from the mu 1. So mu 1 by u. Mu 3 means where the image is formed, where the light is going. Then mu 3 by v minus mu 1 by u, that is equal to mu 2 minus mu 1, mu 3 minus mu 2. Because of here also we can take the mu 1, because of here the another medium is there, so that's why we are getting that mu 3 minus mu 2 by r2, because of which is having that radius of curvature is secondary, so that's why we are taking that mu 2 minus mu 1 by r1 plus mu 3 minus mu 2 by r2 is the lens maker's formula. Then for the any lens having the two principal foci for any lenses, they are that if in case of the when the light is traveling from the one medium to the another medium, means whenever that is moving from the refractive index of mu 1 medium to the refractive index of mu 2 medium, from that also finally it will become make the image at in the mu 3 image. When the light, when we see the when the pen is dropped in the glass, if we see from the outside, light is passing from the air to the glass and glass to the water, whenever we see the bottom of, then some of the refraction will take place. Like that here also we are, whenever we are watching, then the light is passing from the different refractive index of the mediums. So here it is that whenever the light is passing from that, there are two principal foci is there. Then of the first principal focus means light, when the light is passing from a certain point to that, then it will be moves, means here the focus means the object is placed at the focus, then the incident ray is passing like this, and the incident on that it will traveling from the mu 1 to the mu 2, means light coming from the mu 1 refractive index of the medium, the refractive index of the medium, and it will travel into the mu 2 and finally it will merge into the mu 3, converge into the mu 3, because of it's a convex lens called as a converging lens. It converged into mu 3 image formed at infinity distances. So that's why then will if the focus means the principal focus for the first principal focus will happen that for the convex lens is object side, means object is placed this one, so object side the focus is happened. For a concave lenses, the principal focus will be formed at the object or image side, means for the convex lens object side, for the concave lens in case of concave lens image side principal focus will be taken. Then from the formula to find out the focal length for the first principal focus, the focal length is 1 by f1 is equal to minus 1 by mu1, because of refractive index I have taken in the opposite order. So that's why here minus 1 by mu1 of mu2 minus mu1 by r1 plus mu3 minus mu2 by r2. That will stay at a common thing, because of light is passing from the mu1 to mu2 and mu2 to mu3. Finally light coming from the mu1 and light converged into the mu3. So that's why here this will be remains same. Whenever this term will changes from this mu3 minus mu1 get common, then we can get by the calculation we can get 1 by f1 is equal to minus 1 by mu1. Then if in case of for the convex lens, the principal focus will formed in the object side, where the object is placed in the object side. For a concave lenses, then the principal focus will be formed at image side. So here like this, whenever it is means image is formed at infinity distances. Image is formed at infinity distances. Whenever in case of a image is formed at infinity distance, in case of a convex lens image is formed also here as also we can see that when it is also infinity distances from that light moving from that foci. Here is that. So this is about first principal focus, means every lens, any lenses are having their two principal foci. For any lenses there are two principal foci. This is about first principal focus. So this is about first principal focus. If we have the second principal focus, then according to the second principal focus, here when the light is coming from the infinite distances and incident on the lens, and it will converge into the third medium, means which is having the three different mediums, refractive index of three mediums, that is the refractive indexes are mu1 and mu2 and mu3. mu2 is the refractive index of the lenses. Then here when the light is formed at the focus infinity, from the light coming from the infinity, then the image is formed at a focus, that is second principal focus. Then the focal length of the second principal focus 1 by f2 is equal to 1 by mu3 into mu2 minus mu1 by r1 plus mu3 minus mu2 by r2. Here to better to remember the equations, just first listen carefully. This is the r1 and this is the r2. R1 is about mu1 and mu2, so that's why mu2 minus mu1 by r1 means here this is a relation between the mu1 and mu2. Then for the mu3 and mu2 will be the mu2 and mu3. This refractive index of the medium in the side of the second one. So that's why here that we are taking that here r2 mu3 minus mu2 by r2. Light is coming from the mu2 and converged into the mu3. Here light coming from the mu1 and converged into the here mu2. So here it is that to remember the 1 by f2 is equal to 1 by mu3 minus mu2 minus mu1 by r1 plus mu3 minus mu2 by r2 is the focal length, to find the focal length of the second principal focus. From this relations, means from this equation number 1 and from the equation number 2, if we want to find out the ratios between them, then f1 by f2 means the different ratios between the two focal lengths of the lenses, then we can get means the first principal focus and second principal focus, means there are two principal focuses there, so we can say that the foci, the ratio between the foci is equal to minus mu1 by minus mu3, means if divided by equation number 2, then we can get these two terms are same, so that's why they both get cancelled. Then from that equation we can get that minus 1 by mu1 here is there, so that's why we can get minus mu1 by mu3 will be the relation. Then if the focus f1 is equal to f2, focal length of the lenses both are the same, having the same, means the equiconvex lenses, means the f1 is equal to f2. Then the refractive index of the mediums also same, means mu1 is equal to mu3, like earlier we have discussed that lens maker's formula, mu1 is equal to mu3. Then we can get that simply we can say that f as the focal length for the same, means whenever the two principal focus will happen, then the total length will be the remain same. That's why we can take that the focal length is as a f, normal f, we can use that. So from that, if in case of mu1 is equal to mu3, then f1 is equal to minus f2, then simply we use of f as the focal length, means f1 is equal to f2, means whenever it is we take that opposite to the incident light. So that's why we are taking that minus f2, then we can get the equation. Simply use of f as the focal length. This is about the different forms. If in case of the different mediums, light traveling from the different mediums, then the what is the lens maker's formula changes. Then according to this, if the different positions happens, then this is about a first principal focus and this is about a second principal focus. When the both the refractive index of the same, then this will be the equation. So according to our sign convention, the more about the focal lengths in the convex lens and concave lens are here. According to our sign convention, we will take that in the direction of the incident ray is taken as positive and opposite direction to the incident ray in reverse direction is taken as a negative, the values. Then now for the convex lens, when the light ray is incidenting that, here the equiconvex lens is there, which is having the equal radius, that is RR, and this will be the first lens. So that's why this is C1, center of the first one, this is the radius of R, and also here is the second lens. Second lens is having the center is C2, which is having also same radius R. Then the second radius is R2 and the first radius of is R1. Then from that, whenever the light ray is traveling like this, then R1 becomes, if we measure from this side to this side, so that's why R1 becomes the direction of the incident ray, R1 becomes plus R. If in case of when the light ray is traveling this side, we will calculate the distance from this focus to means center of the lens or pole same which is having the less distance, so that's why we will take the same distances. Here we will take in opposite direction to this R2 is equal to minus R. So here it is that whenever we substitute these values in the refraction through this lens maker's formula, then 1 by f is equal to mu minus 1 into 1 by r1. R1 means here plus r minus r2, 1 by r2 means r2 is equal to plus r. We can get that is f is equal to r by 2 of mu minus 1, means here by we can get 1 by f is equal to 1 by f is equal to here mu minus 1 into 1 by r, means here we can get that r 2 by r. Then from that, if we can get reverse this one, then we can get that f is equal to, then denominator becomes numerator and numerator becomes denominator. So that's why we can get r by 2 of mu minus 1. This is a plus. If in case of a concave lenses, here is the convex lenses is a positive, the focal length is a positive. Then in case of the for concave lenses, this one is the first lens, so that's why it is having the radius of R1 and as also R, and as well as here this is the second lens which is having that R2 be the radius of curvature, then radius of the lens, then this is center C2. Then whenever the light is traveling from this direction to that direction, then if we want to find out the distance from this point to this one in opposite direction to the incident ray, so that's why we are taking that R1 is equal to R, means the first lens radius is R1. So we are measuring the distance from the pole to the in opposite direction to the incident ray, so that's why R1 is equal to R. Then if we want to find the distance from this, then second lens, then R2 is equal to plus R, because of we are measuring the distance in the direction of the incident ray, so that's why radius is radius of the lens curvature is R2 is equal to plus R. Then this is the mu be the refractive index of the material. Then we can get that here 1 by f is equal to mu minus 1 of 1 by R1, means we have a value for minus r, because of we are measuring in opposite direction, that is minus r, minus 1 by r2 means in the direction of the incident ray we are measuring, so that's why that is a plus r. Then we can get minus 2 by r. From that 1 by f is equal to mu minus 1 into minus 2 by r we can get. So from that relation, if in case of if we mention that f is equal to, then denominators becomes numerators and numerators becomes denominators. So that's why we are writing that f is equal to minus r by 2 of mu minus 1. Thus the focal length of a convex is positive. Convex is a positive, and for concave is a negative. The values are same here, minus r by 2 into mu minus 1 and here is also plus r by 2 into mu minus 1. Values are the same. So this is about the convention to find out the focal length, more about the focal length whenever we using the equiconvex lenses. Means whenever we take the lenses of refractive index of same, then the focal length we should measure by direction applying the sign conventions.